Variation. This is Unit 7 of the course Applied Algebra or APA. First, we are going to talk about direct variation. This is the equation of direct variation. Y equals k times x. This is read as y varies directly as x, where k is the non-zero constant of variation. So it can also be read as y is directly proportional to x, where k is called the constant of proportionality. These are some of the direct variation equations. Number 1, y varies directly as the square of x. It can be written as y equals kx squared. Number 2, y varies directly as the cube of x. And this can be written as y equals kx cubed. Number 3, y varies directly as the square root of x. And this can be written as y equals k times square root of x. Objective number 1. Determine the constant of proportionality of direct variation. Example number 1. Y varies directly as x and y equals 28 when x equals 4. What is the constant of variation? So this is our equation, y equals k times x, and y here is 28 when x equals 4. So we have 28 equals k times 4. Dividing both sides by 4, we have k equals 7. So our constant of variation is 7. Objective number 2. Solve applied problems involving direct variation. Example number 2. If y varies directly as x and y equals 12 when x equals 3, find y when x equals 9. So this is the equation of the direct variation, y equals k times x. Our y here is 12 and x is 3. So we have 12 equals k times 3. So dividing both sides by 3, we have k equals 4. Going back to our original equation, y equals k times x, we are going to find y when x equals 9. So our k here is 4 and our x is 9. So that means we have y equals 4 times 9. And 4 times 9 equals 36. So this is our answer. We have an alternative solution. We can write y sub 1 over x sub 1 equals y sub 2 over x sub 2. So our y sub 1 here is 12, our x sub 1 is 3, and we are going to find y sub 2 when x sub 2 is 9. So substituting these numbers into our equation, we have 12 over 3 equals y sub 2 over 9. So cross multiplying, so 3 times y sub 2 is 3y sub 2, and then 12 times 9. And 12 times 9 is 108. So dividing both sides by 3, we have y sub 2 equals 36. Example number 3. The distance traveled by a car in a given time is directly proportional to its speed. If a car travels 120 miles at 80 miles per hour, how far will it travel if its speed is 60 miles per hour? So we are going to let d be the distance traveled and s be its speed. So this is our equation, d equals k times s. D here is 120 and our s or speed is 80, so 120 equals k times 80. Now dividing both sides by 80, k equals 1.5. Now we are going to find the distance if the speed is 60. So going back to our original equation, we have t equals k times s. So our k is 1.5 and our s is 60. So we have d equals 1.5 times 60. And 1.5 times 60 is 90. So our answer is 90 miles. Now, let's talk about inverse variation. So this is the equation of inverse variation. Y equals k over x. This is read as y varies inversely as x, where k is the non-zero constant of variation. Or it can also be read as y is inversely proportional to x, where k is computed by multiplying x and y. So these are some of the inverse variation equations. Number one, y varies inversely as the square of x. So it can be written as y equals k over x squared. Number two, y varies inversely as the cube of x. It can be written as y equals k over x cubed. Number three, y varies inversely as the square root of x. It can be written as y equals k over square root of x. Objective number 3. Determine the constant of proportionality of an inverse variation. Example number 4. Y varies inversely as x and y equals 20 when x equals 4. What is the constant of variation? So this is our equation, y equals k over x. And to find k, we are going to multiply x and y. Y is 20 and x equals 4. So that means k equals 4 times 20. So 4 times 20 is 80. Objective number 4. Solve applied problems involving inverse variation. Example number 5. If y varies inversely as x and y equals 25 when x equals 8, find y when x equals 40. So first, this is our equation, y equals k over x. And to find k, we are going to multiply x and y. So our x here is 8 and our y is 25. So that means k equals 8 times 25. And that is equal to 200. Now going back to our original equation, k here is 200 and the value of x here is 40, so we are going to find y. So that means 200 over 40, and 200 divided by 40 equals 5. So this is our answer, y equals 5. Example number 6. The time required to finish painting a room varies inversely as the number of people doing the job. If it takes 5 hours for 9 people to finish the job, how long will it take to finish the same job if 6 more people are added? First, let t be the time required to do the job, and n be the number of people doing the job. So this is our equation. T equals k over n. And t here is 5 hours, and n here is 9. So we have 5 equals k over 9. So to find k, we multiply 5 and 9, and that is equal to 45. Now going back to our original equation, our k here is 45, and then our n here becomes 15. Why? Because originally there were 9 people, now 6 more are added. So that means 9 plus 6, that becomes 15. So 45 divided by 15 is 3. So that means 3 hours. We have an alternative solution. Because this problem is the application of inverse variation, we can have this equation. T sub 1 times n sub 1 equals t sub 2 times n sub 2. And our t sub 1 here is 5 hours, and n sub 1 is 9. Then we have to find t sub 2 when n sub 2 is 15. So 5 times 9 is 45. So we have 45 equals t sub 2 times 15. Dividing both sides by 15, so t sub 2 is 3 hours. Objective number 5. Determine the constant of proportionality of a combined variation. Example number 7. Y varies directly as x and inversely as z, and y equals 18 when x equals 6 and z equals 5. What is the constant of variation? So we call this one combined variation because we are using both varies directly and inversely. So our equation is y equals k times x over z. It's y varies directly as x, so y equals kx, and inversely as z means over z. Our y here is 18, then x is 6, and then z is 5. Substituting these numbers into our equation, this is what we get. 18 equals k times 6 over 5. Now 18 times 5 is 90, so we have 90 equals k times 6, and dividing both sides by 6, we have k equals 15. Objective number 6. Solve applied problems involving combined variation. Example number 8. Y varies directly as x and inversely as z, and y equals 28 when x equals 7 and z equals 3. What is the value of y when x equals 5 and z equals 6? So first, let's formulate our equation. This is our equation, y equals k times x over z. Our y here is 28, our x is 7, and z is 3. So we have 28 equals k times 7 divided by 3. Multiplying both sides by 3, we have 3 times 28, that's 84. So we have 84 equals k times 7. Dividing both sides by 7, our k is 12. Now going back to our original equation, we will substitute 5 into this x and then 6 into this z. And we are going to use 12 for our k. So that means we have y equals 12 times 5 divided by 6. 12 times 5 is 60, divided by 6, that's 10. So this is our answer. Thanks for watching, guys. This is Teacher Rejil. Keep safe.